Thank you, Ben. We have two questions while you were talking. One is, it'll go back to what you were talking about, is the question is, the Valley Center Metropolitan Water District Water Quality Report shows chloride at 500 parts per million and TDS at 1,000 parts per million. How bad is this for avocados?
The chloride at 500 part per million. Okay, it's 100, 1,000. When you exceed 100 part per million chloride or sodium, watch out. You can use that water if it's 150 or even 200, but 500, man, that's real. Where is that coming from? You know, there's a leak in the system. Is this Colorado water or something?
Yeah. Well, it's Metropolitan Water District.
Yeah. Anyway, TDS is 1,000. You know, that's fine. You can get by with it. Okay, 100, 1,000. So you know, it just says watch out. But boy, when you're 500 part per million chloride, you got to do something serious. You got to find some other source of water to leach.
Oh yeah, it says that it came back that water is almost 100% Colorado River.
Yeah, you've got to find some other leaching source. Or you've got to use West Indian variety of rootstocks that can handle chlorides, and maybe in Valley Center it's warm enough.
Yeah, and they tend to make a huge trees, the West Indians. So anyway, here's another question. If you take a root zone, this is both for you and Colette, I think. If you take a root zone soil sample and you measure the saturated soil extract, extracting with the irrigation water instead of pure water that's common in laboratories, you will have the most similar to soil solution that the plant encounters. Wouldn't this be a good parameter to measure?
Yes, it would. And for you at Valley Center on day one, okay? So the thing about soils, and Colin, jump in here at any time. The soil extract can be no lower than irrigation water. I mean, that's a really good point. A soil extract is always going to be higher. And if it's a sandy soil, well-drained, that extract, no matter how it's done, is going to be closer to the salinity of, or the whatever the chemical properties of the irrigation water. On a clay soil, it's going to be higher. There's no way around that. And so, yeah, I think it's a reflection of what you are doing within your irrigation regime, and getting a EC meter, a salinity meter, for $300, and you can go around and you can take soil salinities, and typically you'll find a soil salinity if you're within 2 times the irrigation salinity. So let's say your irrigation water is 1.5 decisiemens per meter, or 1,000, which works out to about 1,000 part per million. And your soil extract that you take, within, the top 8 inches, and you find that it's running 2 decisiemens, you're in the ballpark. If you're running 3, that means it's time to irrigate. You need to get that back into the range of your irrigation water. So actually, you can do your own soil salinities. You don't have to send it to a lab.
So we have a question is, what is the difference between exchange calcium and soluble calcium?
Exchange calcium is what is adsorbed on the soil. Okay, so if you just take a distilled water and you run it through your soil, either 1 or 5 or 10 times the volume of the soil, you're going to get a measure of what is in there. So what is in the solution. But on the exchange, you have to knock that off. And usually they use potassium chloride to do that, or potassium, so that is telling you exactly what is on adsorbed on the soil column. So they're different measures.
So I had a question for Khaled. So, I mean, I found it fascinating that you have this piece of equipment you can drag through a field and measure this, map the salinity in your orchard, but that's great in the San Joaquin Valley, which is flat. But if someone is planting an avocado with a orchard with a slope, that's also not practical to drag one of those through. So is there a substitute type of measurement that you can take that would allow you to generate a salinity map of an orchard, a potential planting site or an established orchard?
Well, yeah, I mean, you could use the same instruments and, you know, drag it around. Or you can do the handheld, you know, just go different locations, so you can still do it. There are other instruments in the market to estimate salinity, but the EM38 is the standard method. So yeah, you can do it on a small scale, you know, just handheld and move it around.
Okay, and how much would that cost per acre approximately if someone wanted to do it? Do you have any idea?
Well, I know there are places where you can rent it, but it's much easier. I mean, if you're a researcher familiar with the method, you can do it yourself, but I would not recommend anybody to do it themselves unless they're really good with electronics and they know how to do the calibration and everything. But there are commercial providers who can do the scanning. I don't know the cost, it's not very expensive. I know, you remember, Ben, we had, when we had the citrus workshop, there were some presentation on, there's a company, trying to remember their name.
Yeah.
Maybe.
Yeah, but you know, Jim Oster used to come out and do the strawberries here, and it's a device that's only about 3 feet long that you just plant down on the soil and you get the reading. So I'm not sure how much it costs, but it's not a big deal.
The cost is about, I think, $9,000 to $10,000, but there are places where you can rent it. But I would not recommend for anybody to rent. It's better to get the service done by a commercial provider.
Yeah,
I cannot just think of the commercial provider. They do everything. They do the scanning and they do the analysis and they give you a report for a very reasonable price. Maybe we should connect with Elia Cesidro from UC Riverside and get his feedback on this.
Okay, great. I would see I have Curtis has his hand raised. Curtis?
You can hear me, I assume?
Yeah.
I wonder if Ben could go over what he just said about if you check your own soil, do your own electrical conductivity on your soil, and if you see that it's greater than 2 times the irrigation water, it's time to irrigate. Or do I have that right? Or
yeah, that's a rough.
That as kind of another way to determine when it's time to irrigate.
Yeah.
Oh, okay. I guess you would have to kind of do that at a depth that corresponds to the root zone of your crop, like shallower with avocados and deeper with
top 6 inches. Yeah.
Okay, thanks.
So we have another question here, a question on leaching strategy in Carpinteria, Santa Barbara with heavy soils and diminishing high pH water supplies. Might it help to irrigate and load up the soil moisture before our increasingly rare rains to take advantage of clean, low pH water to leach the salts from the root zone?
Yes. Yeah, anticipate the rain. Yes, excellent. Because then you get the benefits of the water, and then, you know, any remaining salinity is going to be washed out. Yeah, good idea.
How about when I was thinking about this, when we did the Covey Lane irrigation project, we were in another major drought. I think we were in year 6 or 7 of a drought. And Jim Oster we had soil extraction tubes all over that orchard, and we were measuring the water below the root zone. And I remember, it's in Harvard Graphics, unfortunately, which I can't access anymore, but we had data, we had some beautiful slides that showed that when we finally got that rain in April of 91, how the salt just completely disappeared over a time course. So, but I remember when we started that project, I remember Jewel Meyer recommended at that time that people just turn the irrigation system off in the winter because we had sufficient rain, supposedly. I don't know.
Yeah, coastal agriculture is so difficult, not just for avocados, but everything. It's like, you know, they're forecasting rain. Well, how much rain is rain? Is it going to be 1/10 of an inch, or is it going to be 3 inches? And, you know, the forecasters don't tell you that. And, you know, you've got to be ready to irrigate every month of the year in coastal California.
So do we have any more questions? I don't see anything in chat. I don't see any hands raised. Any other questions? If not, I want to remind you that we have a meeting scheduled for December 1st. And also, while we were speaking, I got an email. Let me pull up the email, see if I can find it. There is a California, Nevada Drought and Climate Outlook webinar scheduled for November 28th at 11 a.m. And it's being put on by the National Weather Service. So I will forward that information to Lorena, and maybe Lorena, you can send that out to everybody in case. I have no idea what, but I mean, it might be interesting to hear what they're going to say about the mega drought that we're supposedly in. And it might be good for thinking about for the future. But I think it highlights also this whole area of salinity and drought is how important it is as we move forward in breeding, that we don't have the ultimate rootstocks and we don't have the ultimate varieties. We need rootstocks, obviously, that are going to be increasingly salt tolerant, and we need sign varieties that are salt tolerant and drought tolerant and heat tolerant. So, you know, Hass is a wonderful variety, but, you know, Hass may not be the variety we need 40 or 50 years from now if we want to have an industry still in California, or if you want avocados in Chile, or you want avocados in some of the more arid areas of Australia or Spain or Israel. So we need to be looking forward to adapt our plant to the changing, challenging environment that we're being faced with. So I'll leave you with that. I hope everybody has a wonderful, wonderful Thanksgiving holiday for those of you here in the United States. And we'll hopefully see you on December 1st, unless there's any other questions.
Thanks very much, everybody.
Thank you very much.
Bye.
Bye.
Bye, guys. Thank you.